Now let us have example of Fourier transform, some elementary functions. So this is first one, see, just e raised to minus at u of t. So basic definition of transform is m of t e raised to minus j omega t. Now m of t will be taken as directly e raised to minus at into e raised to minus j omega t. So total will be e raised to minus of a plus j omega t dt. Therefore, integration of e raised to minus a plus j omega t will be e raised to minus a plus j omega t divided by minus a plus j omega over the limit 0 to infinity. So that comes out to be e raised to this upper limit infinity, e raised to minus infinity is 0 and e raised to 0 is 1. So minus 1 minus minus sign plus, and therefore f of omega, that is Fourier transform of this, will be 1 upon a plus j omega for a greater than 0. Now the magnitude is square root of real part square plus imaginary part square. So coefficient square. So that is an square plus bn square. So similarly, it is numerator magnitude is 1. Denominator magnitude is square root of a square plus omega square. And phase plot is theta is equal to minus tan inverse of imaginary coefficient divided by real coefficient, that is omega by a. And now if we consider some of the sample values at omega, omega is equal to minus infinity, omega equal to minus a, omega equal to 0, omega equal to plus a, omega equal to plus infinity. So substitute all this omega equal to minus infinity here. So therefore accordingly magnitude will be 0 because it will come out to be 1 upon infinity, and omega is equal to minus infinity minus minus plus, therefore phase will be pi by 2. When we put omega is equal to minus a, so here if we put omega is equal to minus a square is a square only, so it will be 2a square, and therefore it will be 1 upon square root of a root 2. So it will be 1 upon a root 2, and phase will be tan inverse of omega is, we are putting minus infinity, minus a. So minus a divided by a will get cancelled, and tan inverse of minus 1, that is minus minus plus, that will become come out to be pi by 4. So tan pi by 4 is 1, and therefore tan inverse of 1 is pi by 4. Now third thing is if we put 0, so 1 upon a square plus 0, that is 1 upon square root of a square, that is a. So 1 upon a, and phase will be tan inverse of 0 minus tan inverse of 0, so that is 0 only. So 0. If we substitute plus a, same fashion like minus a, it will come out to be 1 upon a root 2, and here phase will come out to be minus pi by 4. So like that we can prepare a table from minus infinity to plus infinity, some sample values, and you can draw this way the magnitude plot. As far as phase plot is considered, maximum value is pi by 2, in between value is pi by 4, plus minus both, and therefore the phase plot will look like this. Now one more example where we have two-sided signal, that is e raised to minus a modulus of t, where a is always a positive value. They're going to take positive value. A is greater than 0. Now m of t, how will we will define? E raised to, this portion we will make it e raised to, like it is a rising function with u of minus t. So we will write for this portion e raised to at into u of minus t, and for this portion e raised to minus at into u of t. And now the Fourier transform definition we will apply. So it is integration e raised to at into u of minus t e raised to minus j omega t, and second term will be e raised to minus at u of t into e raised to minus j omega t. Now for first term our limits will be minus infinity to 0, and for second term limits will be 0 to infinity. So same fashion, e raised to something, e raised to something. So that is e raised to a minus j omega divided by a minus j omega. And here it is e raised to minus of a plus j omega divided by minus of a plus j omega. For first term, lower limit is minus infinity, upper limit is 0. So first of all, when we substitute 0, this will be e raised to 0, that is 1 divided by a minus j omega. And when we substitute second limit minus infinity, e raised to minus infinity, so lower limit wise term will become 0. Therefore, only upper limit term 1 upon a minus j omega. For the second term also, when we put upper limit, it is going to become e raised to minus infinity, that is the term is going to become 0. And when you put lower limit, then it will become e raised to 0, that is plus 1. So therefore, this is 1 upon minus a plus j omega. And that minus minus sign, here this is minus sign, is going to become plus. So 1 upon a minus j omega plus 1 upon a plus j omega. So total it will come out to be f of omega is 2a upon a square plus omega square. So for this also, for various values of omega, by substituting, this is your expression. So when you put omega is equal to minus infinity, so this will be whole term and magnitude will be 0. When you put minus a square, so 2a square, 2a, one term will get cancelled, remain 1 by a. When you put 0, then 2a upon a square, that is only one a will get cancelled, 2 by a. So like that, various values, 2 by a will be peak value and rest of the values it will look like this. And as far as phase plot is considered, so phase spectrum does not exist because it is only real term. So 2a upon a square plus omega square. And for phase plot, we are taking tan inverse of imaginary coefficient divided by real coefficient. Imaginary coefficient is 0, therefore tan inverse of 0, and therefore phase plot is 0. So there is no need to draw phase plot. Now, similar fashion, let us go for some other examples in next video.